This is the first video on chapter 23 of weak asymptotes. And in the notes, I give you this function and we look at the asymptotes, and I write g of x in terms of something similar to this. In the notes it has x plus 2 plus 3 divided by x minus 1. And I want to show you a couple different ways to show you how we calculated that. The first is long division. And I'm actually going to work through the steps here for you and show you how to do this. Long division with polynomials is very similar to long division with numbers, and we ask similar questions and we do similar things. It's just I said similar and not exactly the same. And so we start by writing the division sign, and when you do this with numbers, you have the larger number here and the smaller number here. Well, we can't really compare which polynomial is greater than another, so we go by degrees. This is a second degree polynomial, this is a first degree polynomial. 2 is larger than 1. So, and now we ask ourselves, we look at the lead terms, the x and the x squared, and we say, okay, x times what is x squared? Well, x times x. So we write an x in the x position. Now this polynomial is written x squared plus x plus 1. If there's a term missing, I put a 0 there. So if this x weren't here, I would have written this as x squared plus 0 plus 1. So I would use zeros as space holders here if you need to. But we have the x in the x position, and now we multiply x times x minus 1. When we do that, we have x squared minus x. Now we subtract. So we subtract the x squared minus x term from this polynomial x squared plus x plus 1. X squared minus x squared is 0. That's why we chose this x. If this is not 0, we've made a mistake somewhere, either with this, with our multiplication, or our subtraction. But this first difference should be 0. Now remember, subtracting negative x is the same as adding x. So we have x plus x is 2x. And we bring down the remaining terms, which in this case is just the 1. So now we have 2x plus 1. Now, with long division, we would stop when this number is strictly smaller than this number. We don't have numbers, we have polynomials. This is a first degree polynomial. This is a first degree polynomial. 1 is not strictly less than 1, so we keep going. And we ask ourselves, what do we multiply by x to have 2x? And the answer is 2. So we have a 2 up here, so we have x plus 2. Then we multiply the x minus 1 term times 2, and we have 2x minus 2. So we have this term by multiplying the x minus 1 term times positive 2. That gives us 2x minus 2. Then we subtract. (2x minus 2x is 0. Again, we need to get a 0 right here, or we've made a mistake somewhere. Subtracting negative 2 is the same as adding 2. 1 plus 2 is 3. A constant term is a 0 degree polynomial. 0 is strictly less than 1, so we stop. And so we can write this function. When you see the notes, g was written as x plus 2 plus 3 divided by x minus 1. And so we wrote this as quotient plus the remainder divided by x minus 1. And that's what we have here. We have x plus 2 plus 3 divided by x minus 1. What I want to do is show you a faster way to get this term. The thing is you kind of have to think ahead a little bit and break this up in the right way. It's faster than long division, but if you see how to do it right away. If you don't see how to do it, then do your long division. This will always work. But this can save you some time. What did we do here? Well, we have x squared minus 1 divided by x minus 1. No, we don't. We have x squared plus x plus 1 divided by x minus 1. We wish we had x minus 1 because, or x squared minus 1, because x squared minus 1 is x minus 1 is a factor of x squared minus 1. So we broke this up. And we wrote this as x squared minus 1 divided by x minus 1 because x minus 1 is a factor of x squared minus 1. And then we want an x minus 1 because x minus 1 is a factor of x minus 1. So we write this as x minus 1 divided by x minus 1. So these terms reduce nicely. That's why we wrote these. We put these terms here because we want them here. X squared minus 1 divided by x minus 1 is x plus 1. X minus 1 divided by x minus 1 is 1. But now we have to make sure that we save g, okay? So we subtracted 1. We subtracted 1. We need a positive 1 here. So that's why we added 3. Negative 1 plus negative 1 plus 3 is equal to 1. So we write this, and we have x plus 2 plus 3 divided by x minus 1. Okay. Now, this tells us that our oblique asymptote is x plus 2. Because as x gets larger and larger and larger, this term goes to 0. And so the limit as x tends to infinity of g of x is x plus 2. So if we take x plus 2 and subtract this term, the difference is the absolute value of 3 divided by x minus 1. And that goes to 0. So x plus 2, y equals x plus 2, is the oblique asymptote. We learned in the previous chapter that 1 is a vertical asymptote because 1 is a root in the denominator that's not a root in the numerator. So we have our vertical asymptote is x equal to 1. So to graph our function, we follow the vertical asymptote. The limit as x tends to 1 from the right is infinity. The limit as x tends to 1 from the left is negative infinity. And then we follow our oblique asymptotes this way. This point, we seem to have what we call a local minimum here and a local maximum here. We'll learn how to find those points when we start looking at derivatives and how we can tell the shape of a graph of a function from the derivative. So we haven't learned how to find this point and this point yet, but we will.